And what I have here is peanuts, and I'm gonna put it onto the little stand, and then I'm going to light a match, and I'll light it, and I'm gonna put it underneath here. Okay? So when the peanut burns, and you can see some ones from last period already. When peanut burns, it's going to, the heat from it, the energy, is gonna go into heating up the water. And I have a thermometer in here, okay? So let's start with the temperature of the water is, let me see. The temperature of the water on here, 18.48. Can you write that down? The initial temperature of water. 18.48. And I'm gonna weigh the peanut, and I have to use a little dish. Just the first trial, we're doing the first one. We haven't done the second one yet. So I use a little dish so that I don't weigh it right on here. And the mass of the peanut, .62. 0.62, yeah. Put a 0 in the front. Okay, so I'm gonna put it onto here. You wanna get a pair of goggles? Glasses?
Oh, sure.
Let me get you a pair, hold on. Okay. All right, so I'm gonna light the peanut. Did you get the temperature? You did, okay. So I'm gonna light the peanut. And I always have extra water here, just in case, okay? Just so you know. And it is gonna smell a bit. I'm just letting you know ahead of time. Oh, sorry. I did that wrong. I need to put it under here first, so I don't have to move it while it's on fire. Sorry about that. Oops, sorry. I didn't want to put it in the water because it's gonna not light again.
It smells good, honestly.
Okay, so I gotta make sure that the peanut lights. And again, it's not completely accurate, but I wanna make sure. Okay, you see it lit? Okay, so can you maybe go to the side of it? Can you guys see the peanut is burning under there? And you'll see black, right? And you know that that's incomplete combustion, right? It's burning. And let's see what the temperature is. The temperature has already gone up above 19. And when it completely burns out and there's no more flame, then I'm gonna reweigh it, okay? The peanut. Underneath. Do you see it?
I can't see it because it's a small speaker.
Because of this speaker? The speaker?
Oh yeah, now.
Okay.
Where the fire is, that's the peanut?
That's the peanut that's on fire. The peanut is the fuel, right? So we're trying to find out how much peanut, how many calories in this peanut and compare it to the food label. But we're using that energy that's the burning, that because it's the fuel for the flame right here, to heat up the water. And then we're going to calculate how many calories based on how much the water heated up, right? Because energy is always transforming. In this case, it's heat and light, right? Do you see that this is not a closed system? This is an open system because we can see it, we can smell it, and you can feel it. It gets a little warm over here, okay? And once it completely burns out and it's only black, then I'm going to get the temperature change, right? And then I'm also going to get the mass of the peanut. And make sure you guys are writing this down in your Cami. Okay, so is that it?
Yes.
Okay, so I have to get the temperature. It'll go up a little bit, but give it a second. Ooh, smells. 26.70 is the temperature. Okay, so let me get the 26.70, the temperature, final temperature
Of the water?
of the water. Oops, it broke. It's like charcoal. Did you get it? And the peanut is 0.08, the mass of the residue. 0.08. Okay, let's do the next one. All right, so here's the peanut residue. 4 peanuts. Okay, so did you get that? Do you guys know how to calculate the mass of the peanut that was burned? What would you do? How could you calculate that? Oops. Okay. We'll do the calculations together in a moment if you need it, rather. Okay, we're gonna do trial 2. You ready? Okay, the mass of the peanut. Ready? 0.46. Put a 0 in front. All right, so we're gonna put the peanut on here. And the temperature is, oh, I can't even see it. 27.19. All right, let's light this one up. You should at least do it twice. That's why I'm just going to do it twice here. And where's my little...
I'm pretty sure you...
Well, I didn't want to use that one because it's wet and it won't...
What about this
Right.
one?
That's okay. Those are used. You can put them in the water. I can't reuse it. But I use the long stick so that it won't burn my hand.
Miss, you should put this under here first.
Oh, right. You're so smart. Thank you, my assistant. Okay. The first one doesn't always want to light, right? Okay. Okay, second one, ready to go, hopefully. Come on. No, come on. Oh, it went out.
Oh no!
Try it again. Can you change the temperature change on there? It's 26.99. Yeah, for the second one, because this is, yeah.
Miss, will it burn? Because the first part is already kind of burned.
Well, it will, but I'm empty.
Maybe we should just take off the top part so it can just like burn again.
At least we got the first one.
The second one is always harder to try.
Is it lit? Okay, now it's lit. Is it lighting? Okay. Yes. Okay, so you changed it to 26. It's 26.99. Sorry. Trying to be as accurate as possible.
The fire's all over the place.
Yeah. And you guys see the smoke, the black smoke? That's when you get like the soot. Remember, that's carbon. It's black. And it gets all over the can. Because the peanut has fats and protein and carbohydrates. All are carbon based. And when it's burned, it looks like charcoal, just like wood or any other kind of plant-based product would be. Right? That's where the black is coming from. Okay, we're just about done here. So let me get the temperature. Ooh, that smells.
36.
Oh, 31.36 on the temperature. Okay, so let's get the peanut. And we'll knock it off, and then we'll do the calculations. Okay? All right, let's see. Peanut. Broke. And the peanut was 0.06. All right. Thank you. We can calculate the rest.